Welcome to the Tech Explorers podcast, where we dive into innovative technologies reshaping our world. I'm your host, and today we've got something particularly fascinating in store for you, the RadiaCode Python library. If you've ever wondered how we interface with radiation detectors and spectrometers, you're in for a treat. So let's paint a picture here, shall we? Imagine you're entering a lab filled with advanced radiation detectors. You've got your trusty device, let's say a RadiaCode-10x, which has all these incredible features, real-time radiation measurements, spectrum analysis capabilities, and even web connectivity. Sounds like something out of a sci-fi movie, doesn't it? Now, the RadiaCode library makes interacting with this futuristic tech super easy. It provides a complete toolkit to control your device, collect measurements, and dive deep into data analysis, all through Python. It's like having a high-tech command center right at your fingertips. Let's break down some of the standout features. First up, real-time radiation measurements. This allows users to constantly monitor radiation levels as they change, which is critical in fields ranging from environmental science to nuclear safety. Another cool feature is spectrum acquisition and analysis. Think of it like having a musical score that describes the distribution of different radiation energies. It's essential for identifying types of radiation and their sources. What's even cooler? You can connect via USB or Bluetooth. Imagine being able to control the device from a distance, whether at a hazardous site or just from across the room. This flexibility really opens up possibilities for researchers and technicians alike. Now, for those who might be thinking, okay, but how do I actually get started with this library? Well, there's a simple setup process. All you need to do is install the library using pip, and you can launch an interactive web interface that allows you to control the device easily. And let me give you an example of how straightforward this is. You can run a command line to fetch your device's radiation measurements, which can look something like this. So with just a line of Python code, you can connect to your RadiaCode device and pull real-time data. It's as seamless as ordering a coffee with your favorite app. Now, for the developers in the crowd, there are some platform-specific notes to keep in mind. For instance, if you're a macOS user, you might need to install some additional libraries due to Bluetooth limitations. Meanwhile, for Linux users, compatibility is pretty much a breeze. Before we wrap up, I want to leave you with this thought. How does technology like the RadiaCode library affect how we monitor and study radiation in our world? With such tools, we can enhance safety, improve research accuracy, and even help in emergency response scenarios. Thanks for tuning in to today's episode of the Tech Explorers podcast. If you're curious about radiation technology or want to explore further into Python libraries, be sure to check it out. Until next time, keep exploring the wonders of technology.